Now, if we were in class, actually this problem accomplishes a lot because we talked about, in both classes at some point, we talked about compound inequalities, and that's what's being shown here. Choose a number n, so we have some unknown number. But when I read from the n, if I start at the n and read this way, I want the number to be less than 128 in base 10. And if I read from the unknown number this way, it says n must be greater than 16 in base 10. So this compound inequality is basically saying choose any number you want, any whole number. I should have said a whole number that's greater than 16 but less than 128. Like we had 78 on a previous slide, although you wouldn't want to do 78 because we already did that. But something between 16 and 28, but not 16, something between 16 and 128, but bigger than 16 and smaller than 128. Once you pick that base 10 number, like let's say you choose 115 in base 10, try to convert it to binary. Figure out what it is in binary. And if you have someone else, I really love it when I hear that some of you work together on these problems. Ideally, you would give your base 10 number to someone else and have them try to convert it to binary, and then you would check their work. And while they were trying to convert your base 10 number, you would be trying to convert their base 10 number. It's easier to do in class, but y'all work together sometimes online, and so consider doing it that way if you can. If you're doing it yourself, you can still make your base 10 number and then try to figure out what you think it is in binary, and then I'll show you. And I haven't even prepared this. I know for sure that there's going to be a resource out there somewhere. Almighty Google, what is 115 in binary? Oh look, I filled it in. I must have tried that before. Okay, Google itself will tell you. The 0b, don't worry about that, but read the numbers after the b. I don't even know what the 0b means. It might be trying to tell you it's a binary number, but 1110011, that's 115. It's a 1, a 2, no 4s, no 8s, a 16. So far I have 16, 1, and 2, that's 19. And 32 is, wait a minute, 19 and 32 is 51. And a 64, oh yeah, that is 115. Yeah, so you could, or you could even like do a binary conversion. I wonder if calculator, interesting. I wonder what that's going to give me. Let me see. Oh, interesting. Convert binary to a decimal value, convert decimal value to binary. Now, some people would say, why would you show this resource when you're trying to teach your students how to convert binary numbers to decimal values and decimal values to binary numbers? Because now they can just use this tool. Well, look, there's a thing called Wolfram Alpha. There's a calculator. There's all kinds of tools that will do the math for you. But those of you that understand that the point of what we're doing is for you to learn it, would not use those shortcuts. But it's still nice to, just like I always say, if you do the computation go, you do the computation and then use a calculator to check whether your answer is correct. There's nothing wrong with that. That's all this is. You just wouldn't know that this calculator is here unless I showed you. So there's lots of tools to check yourself. So you could do this. You could do this exercise that way, or with a friend. Okay.